humidity and precipitation we are discussing. In the last class, we have discussed how water cycle works in atmosphere with the interaction of a hydrosphere. In atmosphere, water vapor is very important component, and this water vapor present in atmosphere is called humidity. The amount of water vapor present in atmosphere is called humidity. This water vapor varies from one area to another area, from one part to another part of the earth, depending on changing weather patterns. We discussed difference between weather and climate. Weather fluctuates at every moment. So, as there is a change in weather patterns at every moment, water vapor, that is humidity, present in atmosphere also varies. Right? This is the thing we discussed. So, in winter, we feel it is dry and itchy. We feel itchy in the sense we feel inconvenient. By winter, their atmosphere becomes dry so that there is cracked lips for us. When temperature also joins with this dry weather conditions, then we feel sultry and sweaty. It means it is high humidity. That means we call it humidity is high. What is mean by humidity is high? Water vapor present in atmosphere reach to the high stage. So further atmosphere cannot take water vapor. So the sweat which comes from our body has to evaporate. Already water vapor amount is high in atmosphere, so the sweat from our body may not turn to water vapor. Then we feel it sultry. We call it sunbath. In some places on the earth, we feel very dry. That is in desert area. Here, moisture, that is water vapor, it is taken. That means it is derived from water bodies. Water bodies in the sense seas, oceans, lakes, ponds, everything. So water from the water bodies of different types reaches to atmosphere through a process called evaporation. And water comes from our body in the form of sweat when we do some work, right? And that what we call transpiration. Plants, human beings releases sweat through a process called transpiration. So here humidity is high. In high humidity, our sweat doesn't cool us because the sweat which is on our body prevails in the same manner. It cannot evaporate as humidity is, that is water vapor high in atmosphere. In low humidity atmosphere derives water vapor from water bodies and from our bodies. So we feel it is thirsty as water content from our body goes into atmosphere in the process of transpiration. So we feel thirsty. So in low humidity, we feel thirsty. In high humidity, we feel it is what you call sultry. Understand? So that is the thing here. Understand? Next, here humidity is always mentioned in relative terms. What is relative humidity? It is a ratio, that is relative humidity is the ratio between the capacity of the atmosphere to hold water vapor with the actual amount of water vapor present at a particular temperature. To understand relative humidity, here is one example. For example, at 20 degrees centigrade temperature, that means when temperature is 20 degrees centigrade, then at that temperature, at 20 degrees centigrade temperature, the capacity, the total capacity of the atmosphere to hold water vapor is 80 grams. At 20 degrees centigrade, the capacity of the atmosphere is 80 grams of water vapor per cubic meter. This is the capacity of atmosphere at 20 degrees centigrade. But actually, at this 20 degrees centigrade in atmosphere, there is 40 grams of water vapor per cubic meter. So what is the capacity of atmosphere? It is 80 grams at 20 degrees centigrade. That's the capacity. But actually it is holding 40 grams. Still some more 40 grams of water vapor atmosphere can hold, right? So here the relative humidity is 50 percentage. Already the topic we discussed, it is relative humidity. So it is 40 grams. What again I am repeating the point here. 20 grams, it is, sorry, 20 degrees centigrade temperature. If atmosphere holds 40 grams, but actually its capacity is 80 grams of water vapor per cubic meter, then the relative humidity is 50 percentage. It means that relative humidity is the ratio between the actual amount of water vapor that atmosphere holds at 20 degrees centigrade with the capacity of the atmosphere that atmosphere can hold at that temperature, right? At this 20 degrees centigrade, the capacity of the atmosphere is 80 grams of water vapor, that is humidity. But actually it is holding 40 grams. How much it is? 40 grams at 20 degrees centigrade. Actually it is 40 grams holding, but its capacity is 80 grams. So the ratio between these two is called a relative humidity. That means the maximum water vapor that atmosphere can hold at a particular temperature with the actual amount of water vapor present in atmosphere at that temperature is called relative humidity. This is a definition of the relative humidity. Understand? So humidity, that means water vapor. Water vapor starts turning to water when condensation takes place. At a particular temperature, we see that their water vapor turns to millions of tiny water droplets. That is to be called condensation at a particular temperature. And where the condensation starts, at a moment where condensation starts, that level is called saturation level. We call it a saturation level. Understand? At a condensation at a particular temperature when condensation starts. Understand? Here, dear students, relative humidity increases when there is a decrease in temperature. For example, in this example, we have seen at a 20 degrees centigrade, atmosphere capacity is 80 grams of water vapor, but holding 40 grams. If temperature drops to some 15, 16 or some 10 degrees, okay, for example, temperature dropped from 20 degrees centigrade to 15 degrees centigrade, then the relative humidity increases from 40 grams to 60 grams. So that what will be the percentage of relative humidity? It becomes 75 percentage. So when temperature decreases, relative humidity increases instead. Next, going to the condensation. Okay, this is opposite to the evaporation. What is evaporation? Water, liquid form of water turning to the gas form. That is water. That is called evaporation. The process of water turning to vapor. That is called evaporation. And whereas condensation is opposite to it. That means water vapor turns to millions of water droplets, or sometimes it may form crystal ice. Okay, when relative humidity reaches to 100 percentage, understand, when relative humidity exceeds 100 percentage, then you will see that the excess amount of water vapor present in atmosphere starts to condense. For example, at 20 degrees centigrade temperature, dear students, at 20 degrees centigrade, atmosphere is holding 49 grams of water vapor per cubic meter. When it gets cool to 10 degrees centigrade, okay, it means when temperature is 10 degrees centigrade, then the capacity of the atmosphere, that is water vapor which atmosphere can hold, only 40 grams. How much it is? 40 grams. Then excessive 9 grams of water vapor starts to condensation. Condensation takes place when saturation level starts. What is meant by saturation level? When relative humidity reaches more than 100 percentage. What is mean by 100 percentage? It means the total capacity of the atmosphere. Total capacity of the atmosphere to hold water vapor reached 100 percentage. Then after, there is no capacity to atmosphere further to hold extra water vapor. So whatever the extra water vapor is coming to atmosphere, that turns to millions of water droplets, and that what we call a condensation. Condensation also takes place on a contact surface. Have you observed any time taking a thumbs up bottle from the fridge keeping on a table. What do you observe? We observe that some water droplets occurs on the outside of the bottle, right? How it happen? Because this is the bottle very cold, right? So when the cold bottle, this is a cold water bottle or thumbs up bottle, when you place in a area there, what happens? The moisture which is present in atmosphere, when it touches to that cool bottle, then water vapor present in atmosphere gets condensed and turns to the water droplets and appears on the outside of the thumbs up bottle or maybe the glass instead. So this is what we see, that condensation takes place on a contact surface. And the process of condensation, dust particles play very important role instead. Here millions and millions of these water droplets, they come together and forms different types of clouds. Understand? Different types of clouds are formed. Understand? We see that sometimes the clouds may contain ice crystals also. The clouds are further classified into different types. Understand? That is basis on the basis of the formation and the height at which they are found. For example, cirrus clouds, what you call cirrus clouds, which appear at a higher area. This is cirrus clouds. Understand? They appear at a higher level. Understand? Then cumulus clouds, which appear at a middle height. Then stratus appear at a lower level. Then nimbus clouds, which are rain bearing. That means they bring the water rain and they spread vertically. That means from the bottom to top, we see the clouds are very near to the surface. Those are called nimbus clouds instead. So there are different types of clouds based on its height where they appear. Depending on the height where they appear, those are a different one instead. So with condensation, we see that these droplets, millions and millions of droplets, when they come together, it becomes heavy. So atmosphere cannot control it. So it falls on earth, that in the form of what to call plummet, in the form of rain. Okay, and that what we call precipitation. Understand? We call it a precipitation. There are many types. Rainfall is one type in precipitation. Okay, we get fog, we get snowfall. Understand? Different types of precipitations we see. Understand? Precipitation in the sense the water droplets which fall on the surface is called precipitation. In that, rainfall is one. Precipitation is a word derived from the Latin word precipitato. Which word? Latin word precipitato, which means fall headlong. What is it by fall headlong? Water droplets jump from atmosphere to earth's surface. Understand? So fall headlong means that one. So this precipitation may be in the form of rain, right? In the form of rain, right? In the form of rain, snowfall, hail, instant sometimes fog, sometimes sleet. So these are the different types we see in precipitation. Understand? So when condensation takes place, we see all the water droplets, they come very close to the earth surface. Understand? And they fall on the earth surface. Sometimes we see that due to the decrease in temperature on earth's surface, there will be droplets which are light in weight and they fall very very light, very lighter weight of droplets deposited on the earth's surface, sometimes on the plants leaves also. That what we call fog. During the winter we see that early morning we see that some kind of smoke is spreading in the air. We cannot see the person who is in opposite direction to us when we go for morning walking, right? That what we call fog. So due to the what you call droplets which are lighter in weight than atmosphere is covered with fog. So when there is a fog, we see that many accidents takes place instead. So this is about condensation and humidity, right? Next, precipitation. Let us see that different types of precipitations instead. Here, just now I said that rainfall, snowfall, hail, right? Sleet, these all are different types of precipitations. In that, the most common form of precipitation we experienced many times, that is rainfall. Which one? Rainfall is the most common form of precipitation. When condensation takes place at the temperature which is 0 degree, then water vapor condenses directly into the ice crystals. See, if the temperature drops some 20 to 10, then it turns to water droplets. But sometimes when temperature decreases to freezing point, what in by freezing point? At a particular temperature where water droplets or water vapor directly turns to ice crystal, that is called freezing point, understand? So at the freezing point, water vapor directly condenses into ice crystals, understand? It condenses into ice crystals. These may fall on the earth as mass of snow, that is called snowfall, understand? So when we see that freezing point, the temperature decreases to below freezing point, then there will be snowfall, understand? And this snowfall takes place in middle latitudes and high latitudes. In the previous classes, in 8th classes, you have studied tundra region, in near to poles. There is a very less temperature, right? It's those are cold regions. The temperature is below freezing point, so that there you see, instead of rainfall, snowfall takes place. So snowfall occurs at higher latitudes and middle latitudes and at mountain areas due to the freezing point temperature instant. So this is the thing. When rainfall, okay, when rain falls through a cold layer of the air near to the earth's surface, then raindrops also get frozen into the ice and fall down, and that what we call sleet. Instead of rainfall, we see that there will be ice crystals. Ice crystals forms on the earth's surface due to the cold layer in atmosphere. So when water droplets touches to the cold layer of the air, then those water droplets gets into ice and it falls on the earth's surface. That what we call sleet instant. When water droplets touching to the cold layer and turning to ice crystals is called sleet instant. So if ice falls, that what we call it is a sleet instant. And next is that when there are strong vertical currents in atmosphere. Strong vertical currents. What is by strong vertical currents? It means that air molecules starts moving from the earth surface to higher places. Then condensation starts at a higher latitudes. This we discussed. What happens to temperature moving to the higher places? Temperature decreases. So when air molecules which are heated nearby Earth's surface, they rise and they start moving to the higher places. As they reach to higher places, its energy It means which are heated, they lose its heat, that is its energy it loses. Understand? And due to the less temperature, they become ice crystals. Small ice crystals will takes place due to condensation with a low temperature at a higher altitude, right? And these ice crystals gradually grow in a size, and they cannot fall because of the vertical current. As air molecules are coming from the earth's surface to the higher altitude, this vertical air current obstructs what to call these ice crystals which are growing in size do not fall, as a air current is ascending, that means going from bottom to the top, that means earth's surface to higher altitude. So that we see that these ice crystals gradually increases its size. It may increase to a few centimeters, then after it falls as its weight increases due to the density of the ice. That means number of water droplets accumulated and turned to large size of ice crystal, then such a atmosphere cannot hold, then it falls down as a solid masses. Instead, that what we call a hailstorm. In Telugu we call Vadagalna Varsham instead. So due to the what you call vertical air current, we see there ice crystals in atmosphere. The ice crystals grow in size. Okay, they join. One ice crystal with another ice crystal will join. In that way, we see that large size of ice crystals will form and they fall on the earth surface. That what we call a hailstone. What we call hailstone. Understand, dear student? This is called a hailstone. Understand? So here it is what to call destruction to the buildings and damages the water crop. The standing crop also damaged by the hailstones, right? The buildings also get some damage because from a what to call at a greater height, these solid masses comes with a high velocity and touches to the uh, roof of the houses, so that they may get damage. Understand? This is what we call hailstone. Understand? So another important form in the precipitation, that is rainfall. Understand? So there are three types of rainfall, my dear students. Understand? One is a conventional rainfall, second is orographic rainfall, and third is a cyclonic rainfall. Understand? There are three types of rainfalls: conventional rainfall, orographic rainfall, cyclonic rainfall. Let us discuss about these three types of rainfalls. Understand? So here, what is conventional rainfall? This is the one type of rainfall takes place when moist air when moist air, that means air consisting of moisture, is called moist air. So when moist air touches the heated ground, what happens? It becomes warm. Understand? The moist air over the heated ground, it becomes warmer than the surrounding air and is forced to rise. That means the moist air which is touching to an area where it is heat, then this moist air becomes warmer and rises into higher altitude. Understand? So as it rises, then we see that the cool moisture from other area starts coming here. Understand? It means that heated when the moist air over the heated ground, okay, the air is consisting of moisture. When it touches the heated ground, this moist air becomes warm. than the surrounding air, right? And it starts rising into the higher altitude. As it starts rising, it also expands and becomes cool. Okay, and heal some of its moisture. It healed means again it comes back. So conventional rainfall is very common in low latitudes where it is at the equatorial region, which are low latitudes. And summer we see in the interior part of the continents. That means at the middle of the continents we get this conventional rainfall, and it comes for a short period after the hottest part of the day. Suppose today it is very hot, then what we see after the hottest part of the day, there will be heavy showers for short period. That what we call a convectional rainfall, understand, which occurs in the low latitudes and in summer days, that is in the interior parts of the continent, understand. So here it gets what to call for a short period heavy snow, heavy showers we see for short period after the hottest part of the day. In summers we see that, understand. So it comes with thunder and lightning. Lightning also takes place. Thunderbolts occur, understand. So such type of rainfall is called convectional rainfall, understand. So what is mean by convectional? That means the air is moving from the earth surface to higher altitude. Vertically it is moving. So the vertical air current is moving to higher altitude is called convectional. So from that it has come convectional rainfall. Understand?